Well, AC and DC, as the abbreviation stands for alternating current for AC, and DC is a direct current. Now the symbols for AC and DC are represented, and here AC current is fluctuating in the sense that 50 to 60 times per second the polarity is changing, and it is also sinusoidals, and sinusoidals concepts enables the AC to be expressible in the forms of exponent. That means you can express AC in e to the power j omega t forms, and this fluctuation nature of AC can be well visualized if connected by a ball. It will glow and off of a connected AC source of below frequency range of perception of our eyes, which is 1 of 20th to 1 to 30th depending upon the individuals, and no such glow off and on for DC is observable. So that means if you connect a ball and very carefully you can mark, the ball will glow and off in case of a AC source, but that will never happen in case of a DC source. And accordingly the sinusoidal natures enables the AC current to be represented in a sine and a cosine forms. Here I is obviously a simultaneous function of frequency and time, but in case of DC the current is steady, it is unidirectional, and accordingly the current bears a constant value with respect to times, and it depends only on potential and resistance. The curve is as shown as I versus T graph, and I here we express as V by R, which is constant. Only it depends upon the potential and resistance. Now the AC can be easily converted to desirable forms, various desirable forms using transformers. AC transmission for long distance is also economical because at high voltage the line losses is minimized, and AC can be converted to DC by rectifiers as we have seen. But in case of DC, production is costly compared to AC, and a long distance transmission is not suitable also for case of DC. DC conversion to AC is unusual. Now in cases of uses, most of our domestic uses using commercial power supply companies uses AC currents. But in case of DC, we mostly uses in laboratories like in Lackland cell, Daniel cells, dry cells, wherever the electrolysis process is there leading to motion of charged particles or ions or even electrons, giving rise to currents. And also we use DC in case of railway engines, in toys and in torchlights. Now beyond the comparison of AC and DC, we must remember few things, that is electrical gadgets for each of AC and DC are different. AC is mainly a surface phenomenon, and hence the skin depth for the conductor is most important concerns. And frequency dependent electrical components like your capacitor, inductor behave differently when connected to AC and DC sources. Accordingly, we use the terms resistance, conductance for DC, and impedance, that is reactance and susceptance, admittance also we use for AC. We will discuss more about these terms in our subsequent discussions. Thank you.